Assalamualaikum warahmatullahi wabarakatuh, and good morning. Bismillahirrahmanirrahim. Today we will conduct for the experiment 1. For the experiment 1, we will do the general safety symbol, schematic diagram, pictorial diagram, datasheet, tools and type of equipment. For this experiment, they have two objectives to achieve. The first one is to motivate and expose students to laboratories environment and safety precaution in the laboratories, to expose the student to equipment or components, electronic and electrical symbols. Okay, they have 4 equipment. The first one is the oscilloscope, multimeter, function generator and also the power supply. This experiment divided into 4 parts. Part A will cover for the safety rules. Part B will cover for the basic test instrument. Part C will cover to the introduction to electrical symbols, schematic diagram and pictorial diagram. And finally, part D will cover for the basic hand tools. For the part A, which is the safety rules, refer to the previous page for list of safety rules, lab regulation and precaution. Study the safety rules and regulation. Now this is the list of safety procedure and rules. The first one is students should come to laboratory session on time with the proper dress, lab coat and shoes. No slipper are allowed. Students are not allowed to enter the laboratory without permission from the lecturer or technician. Working alone with the unsupervised laboratories are forbidden. Bags are not allowed in the laboratories. Put them on the shelf provided. Read the instruction carefully and follow the laboratory's procedures. Do not touch anything with which you are not completely familiar. Never eat, drink or smoke while working in the laboratories. Never run the experiment with a wet hand or wet body. Never run the experiment when you are sleepy or when you are take a drug medicine. Ensure that your circuit and equipment connection are correct before power supply in on. Ensure that the switch are off and the plug are unplugged before you leave the laboratories. Place the equipment, tools and components back to their original place after the experiment. Notify your lecturer or instructor immediately for any accident. Now go to the procedure. Student required to answer 5 questions here for the part A. List down 5 safety rules when working with the high voltage. So student can refer to this part to answer the question. Thank you. Part B, basic test instrument, will cover for the 4 component: oscilloscope, multimeter, function generator and also the power supply. Oscilloscope. The oscilloscope provides a 2-dimensional visual display of a signal. Most commonly, it is used to show signal amplitude versus time, thus displaying the waveform of the signal being monitored. Some oscilloscopes have 2 or even 4 input, all using the common time base, so the signal amplitude and shape as it progresses through the stage of the input and the test can be examined and also the compare. Now refer to the explanation about the oscilloscope. Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Today we will see the oscilloscope. The basic function of the oscilloscope is to provide a 2-dimensional visual display of a signal. The oscilloscope that we use in UiT and Pulau Pinang is the Agilent technology, model name DSOX2012A, model name. The oscilloscope can be divided into 2 parts. One is the display part and another part is the signal control part. Now we will turn on our oscilloscope by pressing the on off button here. Now our oscilloscope is ready to use. This oscilloscope have two input signal where it's divided into channel 1 and channel 2, and this is the input signal connection where we can use to measure our signal here. So this is the channel 1 and also this one is the channel 2 input connector. This is the probe that we use to measure our signal here. Now we will attach our probe to the channel 1 to measure our signal. Okay. This probe have two polarity, negative and also the positive. This one is the negative polarity and this one is the positive polarity. This oscilloscope have internal signal generator to visualize signal. Now we will attach the probe, the negative probe at here and positive probe at here. As you see in the display panel, we have a step signal here, which is generated by the oscilloscope. Now at the control panel, we have a few basic buttons that we can use to control our signal. The first one is the run and also the stop button. So this button is function to stop or moving the signal. Next is the auto scale or auto set button. So this button is to set automatically control to produce a usable display of the input signal. Next is the measurement button, this button here. So the function of this button is to measure our signal. Next is the horizontal knob. So this horizontal knob is to move signal on the X direction. Now we start the signal here. So as you see, the signal is moving on the X direction. The second knob is the vertical knob. The function of this vertical knob is to move signal at the Y direction. So as you see here, our signal is getting more higher when we increase the knob at the clockwise. That's all for the brief introduction for our oscilloscope that we use in UiTM Pulau Pinang. Thank you. Okay, at the procedure. Part B, basic test instrument. Identify all the basic button on equipment below. Part A, oscilloscope. Refer to the figure 1.4, show the front panel of the oscilloscope. Identify all the basic button on the equipment listed in the table 1.1. So student need to answer for the question which is asked in the table 1.1. So you need to identify the button or the connector. For example, display the automated measurement menu. So refer to the here. So what is the menu is used to display, or the menu function for display the automated measurement menu? It's the measure. Now for the part B, basic test instrument, multimeter. A multimeter is an electric instrument capable of measuring voltage, current and resistance. Digital multimeter have numerical display like digital clock for indicating the quantity of voltage, current and or resistance. Analog multimeter indicate these quantities by means of moving point over a printed scale. Now go to the explanation of multimeter. Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Today we will see the multimeter. The basic function of the multimeter is an electrical instrument capable of measuring voltage, current and resistance. In UiTM Pulau Pinang, we are using this multimeter, Agilent multimeter. The model is 34401A. Now we will turn on our multimeter by pressing this on-off button. So in this multimeter, it divided into three parts. One is the input panel, this one is the control panel, and this one is the display panel. For example, if we want to measure the voltage, DC voltage, so we need to set or press the button. This here is represent the DC voltage, and for the AC voltage we just press the AC V here, which is to measure the AC voltage. Next, if you want to measure the continuity of the circuit, we just press the button const here. Okay, so if we want to measure the DC current here, we need to press the button shift here and with the DCV here. Now if you see at the display panel here, it show the MA DC, which is represent milliampere direct current. DC is represent the direct current. The same thing if you want to measure the AC current, you need to press shift and ACV here. So the display panel also show the indicator of to measure the AC current here. Okay. Okay, now we do some example how to use this multimeter. First thing, we need to use probe. We need to use probe. Okay, to measure the voltage. Okay, so if you see here, okay, we have the terminal, three terminal here, red, black and also red. So the first terminal here is represent the voltage. This symbol represent to measure how to measure the resistance and also the diode. Okay, the third terminal here, the red one, is represent how if you want to measure the current also. Here, if you see on the left terminal here, the red one also used to measure the resistance here. This is the indicator what's the type of measurement if you want to measure. Okay, this one is the ohm for watt, and the maximum voltage that can be support for this terminal is 200 volt, and for this two terminal is 1000 volt. Normally we will attach our terminal to these two terminal here, which is 1000 volt maximum. Okay, so now I attach the positive probe here and negative probe here, and I want to use this probe here to measure the DC voltage. Okay. Okay. Right. Alright. So from this probe, I will attach to the power supply. So this is the power supply. Okay. And this power supply also have the terminal, negative terminal. I put the negative probe, and positive terminal I put the positive probe. Next, I will DC volt here. I press this button, so the panel show the selection that we use here is the voltage DC. Okay. Next, I will turn on the power supply. Just press the green button at the power supply here. Okay, now you see the multimeter show the result of our power supply is 5 volts, around 5 volt. Okay. Now if you want to measure the current, firstly you need to turn off your power supply and change the multimeter probe, the positive terminal to the third positive terminal, which is represent the I here, current. If you see here, we have I symbol is represent the I, represent the current. Next, you need to press the button shift DCV and for selection of current, DC current. After that, you turn on your power supply. Now you see the result of the current that produced from the power supply, which is 0.46 ampere. Okay. Alright, so this is how you want to measure the DC voltage and also DC current. Next example, we try to measure resistance value for this resistor. Okay, for this resistor. Okay, so you turn off the power supply, then you need to change again the positive terminal and put at the first terminal of your multimeter. Okay, then take the probe. So this resistor, basically resistor is the passive component, so it didn't have any polarity. Okay, you just tap the probe between these two legs, and of course you need to change, you need to select ohm here to measure the resistance value. Now like this. Okay, so if you see at the display terminal of the multimeter, you see the value of the resistance, which is around 0.986 or 7 kilo ohm. Okay. Alright, so next, if you want to measure the connectivity, we just press this button. Okay, then you just tap your probe like this. Okay, if you heard the sound, so it show that they have a connectivity. So basically this type of measurement, or to measure the connectivity of the from our circuit. Okay, so that's all for the brief introduction for the multimeter. Thank you. Assalamualaikum warahmatullahi wabarakatuh. And do not forget to turn off your multimeter. At the procedure section, multimeter. Figure 1.5 show the front panel of the digital multimeter. Identify all the basic button on equipment list in table 1.2. So this is the front page of the digital multimeter, and this is table 1.2. So Student required to answer all the question in the table 1.2. They have 5 question and student need to identify the function of the button. For example, to measure DC voltage, what is button used to measure DC voltage? The answer is DC V. Referring to the front rear input terminal switch of the digital multimeter shown in figure 1.6. This is figure 1.6. Above indicate the connector combination used for 1. Measuring voltage, measuring resistance, measuring current, testing diode polarity, testing breadboard connectivity. Student need to answer the question related to the based on this figure 1.6. So what is the connection required to measure the voltage? So the answer is A and B. So refer to the video explanation. So you need to answer the rest question. Thank you. Part B. Test instrument. Function generator. This device provides one or more waveform at various frequency. Typically, waveform are sine wave, triangle wave, square wave, and narrow rectangular bus. Refer to the application of the function generator.
This is the image of function generator. It is a device that can produce various patterns of voltage at a variety of frequencies and amplitudes. We can adjust the frequency, set the shape or function, and change the amplitude level. It is usually used to test the response of circuit to an input signal that we know. Let's take a look of a front panel of this function generator. First, of course, you have a power switch to toggle the instrument power on and off. Arrow 1 is a large LCD display to display both frequency and level peak-to-peak amplitude and RMS value of a voltage. Arrow 2 is a frequency range button. It shows the range of frequency that we can select from 5 Hz to 5 MHz. This reading selection is shown on the LCD display. Arrow 3 shows the 2 frequency knobs located on the bottom left of the function generator. It adjusts the frequency within the range set by the frequency range button. The small knob labeled as 3A used for fine tuning the frequencies. Once the frequency has been set, by pressing the lock key labeled as 3B, this device will give a level of frequency stability. Means you will get the stable frequency reading. The knob determines the frequency of the function generator output. For example, if the frequency knob is set to 5, and by pressing the 500 Hertz button at the frequency range, the output function generator will display 500 Hertz shown in the LCD display. Arrow 4 is a function buttons. It selects the type of waveform generated such as sine wave, triangle wave, and square wave. Arrow 5 is an amplitude knob. It is used to adjust the amplitude of the waveform. Arrow 6 is a main out connector. It is an output terminal of the function generator. This connector sends sine, triangle, and square signals to electric circuit. The DC offset knob is shown in arrow 7. It adjusts offset voltage. Arrow 8 is a sweep button. It activates the internal sweep generator. This button enables the sweep rate and stop rate knobs. Arrow 9 is a sweep in and out connector. This connector sends sweep signal that you can adjust with the sweep controls. Symmetry button is shown in arrow 10. It selects either positive pulse or negative pulse. Here are some examples of the effect of the symmetry button on output. Arrow 11 is an AM counter input connector. This connector accepts external amplitude modulation signals. Arrow 12 is an attenuation button. When you push in the button, the function generator attenuates the incoming signal. Means the peak-to-peak input levels must be between 5 volt to 20 volt. When you push the button out, the function generator does not attenuate the input signal. Means the peak-to-peak input level must be between 2 millivolt to 5 volt. Arrow 13 is a peak-to-peak RMS button. Its function is to switch between peak-to-peak and RMS value of voltage. The offset button is labeled as arrow 14. It is to switch the offset voltage. Here are some connections examples of function generator to oscilloscope and some electric component that you can see.
Procedure Part B. Basic test instrument. Function generator. Student required to answer question in table 1.3. Student required to identify the function each button for the function generator. For example, switch between peak to peak and RMS value. What is the button or connector related to this function? The answer is P button. P button. Part B. Basic test instrument. Power supply. The basic purpose of a power supply is to provide a fixed voltage to the working circuit with the sufficient current handling capacity to maintain the operating condition of the circuit. Refer to the explanation of the power supply.
A DC power supply is used to generate either a constant voltage or constant current. It may be used either as a DC voltage source or a DC current source. In this lab, the DC power supply will primarily be used as a DC voltage source. This power supply provides two separate DC voltage output. Let's name these two separated DC voltages as channel 1 on the right of the panel and channel 2 is on the left of the panel. Each of the channel delivers 0 to 10 volt and 0 to negative 10 volt output. Here is the front panel of the DC power supply. Arrow 1 shows the power switch to power on and off the DC power supply. Positive terminal are shown in arrow 2. It is used to output the voltage. Arrow 3 is the ground terminal. This terminal is connected to ground wire and is in grounded state. The control knob labeled as arrow 4. By using this control knob, we can adjust the voltage as a selected output. Arrow 5 is LCD display. It is to display the voltage of the selected output. This power supply can generate negative power supply by connecting the positive terminal of channel 1 to the negative terminal of channel 2. The negative terminal of channel 1 is then the negative output, and the positive terminal of channel 2 is the positive output. Figure 1 shows the terminal connections on how to get the negative power supply. The DC power supply output terminal accept banana connector terminated and alligator clip terminated for use with DC power supply. Figure 2 and 3 shows the two connections, the two connectors images. Figure 4 and 5 shows some examples of a DC supply, some connection example of a DC supply to other equipment and component.
Procedure. Part B. Power supply. Figure 1.8 show the front panel of a power supply. Identify all the basic components on the equipment list in the table 1.4. So this is table 1.4, and this is the figure show the front panel of the power supply. Student required to answer all the question inside table 1.4. For example, the function of the positive terminal. What is the button or connected related to it? For example, for this question, the answer is C. Part C. Introduction to electrical symbol, and schematic diagram, and pictogram. The rest, electrical symbol. An electronic symbol is a pictogram used to represent various electrical and electronic devices such as wire, batteries, resistor, and transistor. In a drawing of an electrical or electronic circuit. Figure 1.1 shows some of the most common symbols used in a schematic diagram. Okay, so this is a figure 1.1, list of a common symbol. So this is the component battery, and this one is the symbol for the battery. Okay, this is the DC supply, okay, AC supply, transformer, hertz, inductor, and so on. Okay, you can refer to this table or this figure for the electronic component and with its symbol. Schematic diagram. The schematic diagram consists of idealized circuit element. Each of schematic diagram. The schematic diagram consists of idealized schematic diagram. The schematic diagram consists of idealized circuit element, each of which represents some property of the actual circuit. A well-drawn schematic makes it easy to understand how a circuit works and aid in troubleshooting. A poor schematic only creates confusion. By keeping a few rules and suggestions in mind, you can draw a good schematic in no more time than it takes to draw a poor one. Rules of drawing schematic or circuit diagram. Drawing circuit diagram is not difficult, but it takes a little practice to draw neat, clear diagram. Follow this tip for the best result. Make sure you use the correct symbol for each component. Draw connecting wire as straight line. Put a block at each junction between wires. Label components such as a resistor. Rule of drawing circuit diagram. Drawing circuit diagram is not difficult, but it takes a little practice to draw neat, clear diagram. Follow this tip for best result. Make sure you use the correct symbol for each component. Draw connection wire as a straight line. put a block at each junction between wires. Label components such as resistor and capacitor with their value. It's the best to give all part of a label. For example, R7 represent the resistor 7. IC3 refer to the integrated circuit 3. The positive plus symbol here, the positive supply or the plus symbol should be at the top, and the negative symbol, negative sign here, supply at the bottom. If the circuit complex, try to arrange the diagram so that signal flow from the left to right. Input and control should be on the left, output on the right. Okay, so you may omit the battery or power supply symbol, but you must include a label, the supply line at the top and the bottom. So this is a circuit which is the good drawing circuit, and this is the bad drawing circuit. If you see all the symbol they have, positive, negative symbol represent the battery and resistor here, and also the lamp. But here is the connection between the battery and resistor is not a good connection, or the connection is not straight lah. Okay, so try to use a ruler when you make a connection between any component. Okay, picto diagram. A second type of electronic schematic diagram is the picto layout diagram. It's actually not so much an electronic schematic as a pictorial of how the electronic circuit actually look as in the figure 1.3. Okay, so this is the picto diagram, this is the schematic diagram. Okay, this drawing show the actual layout of the component on the circuit board. This provide a two-dimensional drawing, usually look down from the top, detailing in the component and their location. Okay, so the picto diagram is when you the component for when you draw the picto diagram. So we using the 2D dimensional image, like this one is the lamp. Okay, this one the symbol for the lamp. So this one is the actual okay, we can say the actual symbol for the lamp. Okay, in the 2D, this one is the battery, this one is the symbol of the battery, and this is the connection. We still using the straight connection to connect from each component. At the procedure. Okay, so this is the task that you need to answer for the part C. The first one, picto diagram and schematic diagram. Draw appropriate schematic diagram of the picto diagram shown in figure 1.9. Okay, this is figure 1.9. So you need to draw the schematic diagram represent for each picto diagram here. So here I show to you the first example here, for the first question here, how you want to answer for this question. Okay, so this is the picto diagram, so you need to convert to the schematic diagram here. So you need to convert to schematic diagram. Okay, so from here I cannot draw like using the ruler, so just a scratch here only. So the first one is the battery. So we have 4 battery, 1, 2, 3 and 4. So this is the symbol for the battery, and this is the polarity, plus minus, plus minus, plus minus, so plus minus here. Next we have lamp. We have 2 lamp, lamp 1, lamp 2 and lamp 3. So the symbol for the lamp 1, for the lamp, like this. Okay, and also we have 3 lamp. Okay, so this is the positive and this is the negative, connect to the lamp 3, and the positive here connect to the lamp 1. So this is the schematic diagram for the for this picto diagram. Okay, so you can use okay, also you can refer to the previous example how you want to draw the schematic diagram. So for the rest, you need to answer from the given box here. Okay, next, component of the electrical symbol. So refer to the figure 1.10, list down all the component used. For example, this one is the regulator. So what is the, this is the function of the IC, which is the regulator, LM317 and LM337. And you can put also here the next component you can put here is the, for example, a resistor. Okay, we have the resistor. So you can write down here what is the okay, for the part B, component and electrical symbol. So this is the schematic of the circuit. Okay, so refer to the figure 1.10, list down all component used. For the first one is the regulator, LM317 and LM337. So from here you need to identify all the component that used for this schematic. For example, this one you can see what the component you see here. So we have resistor. This one R1 is the resistor. So answer here lah, resistor. Then you have this one is the variable resistor. Okay, this one is the variable resistor. So you answer for the third one is the variable resistor. All the symbol here you can refer to the previous from here. From the previous note here, we have all the symbol here. So by refer from this list of component or common component symbol, so you need to answer for this question. Okay, for this question. Okay, so you have variable resistor and so on. Okay, so part C, component and electrical symbol. So you need the figure 1.11 show the schematic circuit. For the schematic circuit, refer to the figure 1.1, indicate the component label and also the number. So in here you give the component name, which is the, for example, we have the inductor. So you need to refer to the same thing from the previous figure, which is the common symbol of the component. So what is the inductor? You need to identify where is the inductor. So for example, the inductor is this one. This one is the inductor. Okay, so you put here label. Here is the 6, and so PNP transistor. So where is the PNP transistor? Okay, and so on. So answer all the question here. Next, determine the value of the following component including their unit R1. So refer to the R1. Okay, what's the value of the R1? So R1 is the value is 1.5 kilo ohm. So you need to put here 1.5 kilo ohm. This one. Okay, 1.5 kilo ohm. So 1.5 kilo. So we set the symbol. So we have any symbol here. Oh yeah. No, this one. Sorry. Okay. Okay, 1.5 kilo ohm for the value of R1. Okay, that's all for you need for the experiment for the section C. Okay, thank you very much. Part D, basic hand tools. Common hand tools such as screwdriver, plier, long nose and soldering iron are required when working in the laboratories or project. Refer to the explanation for basic hand tools.
Let's move on to part D, which is about basic hand tools used in the laboratory. There are many tools used in the lab, such as pliers, screwdrivers, claw hammers, vice grip, knives, scissors, adjustable wrench, sucker, measure tape, and so forth. You can see all these tools in image 1. Of all these tools, there are some basic hand tools that you need to know. Here are some basic hand tools images such as pliers, screwdrivers, trimming knife, wire stripper, measuring device, hammer, drilling tool, and soldering tools. We will go on detail about these basic hand tools later. Now, we move on to pliers. There are many different types, shapes, and sizes of pliers. They are used for cutting wires, twisting wires, bending wires, or holding and gripping wires. And not just wires, as well as cables. This is an example of a plier. It is called a cutting plier. It is used for cutting wires. Next image is a long nose plier. This tool used to grip small object, holding wires, bend loops, or attach wires. There are several. These are several examples of pliers. Now we move on to screwdrivers. A screwdriver comes in many sizes and also with several thick shapes. They are used for loosening, tightening screw. Some examples of a screwdrivers are a slotted head screwdriver, a slot head screwdriver, and posy screwdrivers. Next is a wire stripper. This tool is used to remove off insulation from the tip of each wire. The next tool is a trimming knife. It can be used for cutting wires or cables, and also can be used for stripping off the plastic insulation of a wire. The next image is a hammer. Hammer are used for nailing and fitting. You can see some example of hammers and their functions in the image that I've given you. Next is a drilling equipment. Drilling equipment is used to make holes in building structure of conduit and wires. Measuring tools such as a steel tape is used to measure wire length and other items. Next is an image of sewing and cutting tools. These tools is commonly used for crosscut, keyhole, making a keyhole, and hacksaw. Here is the image for basic soldering tools. What is the term soldering means? Soldering is a joining process. It used to join different types of metal together by melting solder. Look at this image. This is a soldering iron. Its function is to heat the solder. Therefore, the melt solder can flow into to join between two work pieces. This is a solder wire. It is a metal alloy used to create strong permanent bonds. Example, copper joining in circuit board. Here is a solder sucker. It is a device to remove solder from a printed circuit board. Here is a soldering blade, or sometimes it is also known as soldering wick. This item usually supplied on a roll. It is used to remove solder, which allow component to be replaced and excess solder to be removed. This is a vice tool. This tool is used to hold our workpieces so that we can have our hands free when working with soldering iron and solder. Next is a safety glasses. It's for eye protection at work or during your soldering work. This is a damp sponge. Damp sponge used to clean the soldering tip by wiping the soldering tip on the damp sponge. Or instead of using damp sponge, a brass sponge can also be used to clean the soldering tip. Just push the soldering tip up and down into the brass sponge.
Here, part D, basic hand tools. Identify the following tools and write their corresponding label into table 1.5 below. Refer to the panel catalog for their details. So this one you can refer to the through the website of the funnel. So this is table 1.5. So you need to identify the labels, the tools which is referred to this item. For example, cutting plier. So what is the component related to this tools? So the answer is C. Okay. And also for the basic soldering tools. So for example, soldering iron. So you need to identify what is the item or tools that related to this task, soldering iron. So the answer for this part is D. Okay. So you need to answer the rest of the question. Thank you.